Jennifer Gutierrez, and I am going to talk about the penetration of chloride in concrete due to temperature variation. In summary, an analytical equation was developed to determine the coupling parameter based on the test data. Introduction. The majority of reinforced concrete structures such as bridges, roads, parking garages, marine structures, and buildings are subject to a surface environment that has simultaneous chloride ion penetration and temperature variation. There are two approaches to assess chloride penetration process in particular. One is based on fine dissemination theory at the macroscopic level and only talk about chloride. The other is based on the Nair-Einstein equation and the Nair-Plus equation, considering multiple transference, in particular including chloride. The experiment, a multiple-scale approach, was used to link the micro and mesostructure. For research, several characters intervened. Who discussed the coupling between H, R, and T, and the development of a model to calculate the effect of coupling of R, H, and Cl in moderately saturated concrete. There was also talk of evidence of the effect of chloride penetration in the presence of moisture. The effect of moisture transference about chloride penetration and the tests that show that the effect of moisture transference on chloride penetration is significant. The innovation of this document. First, establish a new test method to obtain relative results for concrete under simultaneous chloride transference and heat. And second equation, which can be used to determine the coupling parameter DCLT based in the test data obtained. Experimental program. For the experimental method, 3 tests were taken. The first is a regular estimation test while only one force acting condition. The second is modified estimation test at constant temperature. There are 2 driving forces for chloride penetration. One is the concentration of chloride gradient, and the other is Series 1. 3% chloride concentration. Series 2, chloride 5%. Series 3, this series has the same temperature conditions as the first series, but with a lower water-cement ratio for the concrete. The temperature gradient. The third also a modified stagnation test. Experimental result and discussion. In the presentation, we observe the internal temperature distribution and the temperature registered at different levels in function of time. Conclusion. The effect of temperature variation on chloride penetration significantly increases the chloride penetration process when the temperature gradient and the chloride gradient they are in the same direction. Therefore, the coupling effect must be considered in the analysis. After a prolonged period, only the chloride gradient affects the chloride